hopefully we can cover some basic thing about modeling. And today we have a particular or special application with Agarwood Essential Oil grading or quality grading determination via our modeling. Before that, I hope you can allow me to introduce my new workplace. As Dr. Wan mentioned just now, this is my second week at my new workplace, Mitrans, or Malaysia Institute of Transport. Here we study, we do research, we do consultation, and we do certification for several trainings. And generally this cover 3 major areas: transportation, logistics, and halal supply chain. And we also offer 3 academic programs. One is a diploma program for a special client, and we have 2 postgraduate programs: Master of Science in Transport and Logistics, and also PhD in Transport and Logistics. And I would like to welcome those audience today. Any of you wanted to do or collaborate with us for these courses and other research, please do so. Our current tagline is transporting happiness, and we want everybody to benefit from our existence. Whatever we do, hopefully can benefit you all out there, either you're an individual, society, industry, and etc. So I hope even today, I hope the sharing that I and Dr. Laila want to share with you all will be sort of something will make you happy. Right, what's the expectation from today's presentation? I'm expecting that some of our sharing today hopefully can relay the basic understanding of modeling. I'm sorry for those of you who are already used to modeling and you may be already advanced or have advanced in modeling. Today is just going to be quite basic and general in nature, because I'm not so sure you all, the participants today, are not sure of your background. So our approach today just going to be general and maybe basic, but I promise you it's going to be fun. And as I mentioned earlier on, Dr. regarding the whole pandemic issues and the economic crisis that we have now, you can roughly estimate that, you see, if you go back before in Malaysia and in the world, we have some economic crisis in 86, and then we have another one in 97, and then 208, and 2019 or 2020. So such what you can sort of use for some prediction or for forecasting. Well, that's the side story about this time series. So process or system where we can regulate, or we can measure input data or input variable, then we can have single input, single output system, or multiple input. Can be many outputs as well. So we can have CISO or CMO or MISO or BMO system. For example, we may have this data regarding GDP per capita and the happiness indicator of the population. I'm picking up this from somebody. And you see this input-output data can be regressed into a linear model, for example. You see the straight line here, there's a straight line fit, and normally we can linearize the representation of the expectation of happiness with the GDP per capita. This is normal. I mean, the more money you have or the more financial freedom you have, the better will be your happiness or your joy index. So coming back to system modeling, I'm going to apply system identification method. And I think early 60s, Zadeh defined this. Is identification is the determination on the basis of input and output. So normally we have input and output. So you have a pair, or you have multiple input or multiple output. You have many pairs. But sometimes for a time series, you only have a single output, no input. You can do that. You can model that as well, and you can do identification of that variable as well. So if we get that data for that system, then we can study that and we can identify appropriate model for that system. And normally the steps used, or people normally apply, I do this, I think the famous author in system identification, June, for example, or my previous supervisor in Sheffield, Professor Billing, used similar, or I in fact adopted their techniques. So the first step, you do experiment. Experiment means maybe you measure input-output data. From the input-output data, then you select a structure for it. I think later on there'll be some slide describing this. And once you have, for example, previously I mentioned to you, linear structure, or can be non-linear structure. So that's model structure. Linear structure is just as easy as y is equal to mx plus c. Y is your output, x your input, m is the slope representing the relationship between your input and output, and c is just offset in your data, or your cut off on the graph. So that's a simple linear model. Non-linear model can be an advanced AR model, for example, RMAX, NAMAX, and etc. So or black box model based on fuzzy logic, artificial neural network, SVM, and many other structure that we can select. Sometimes the structure can be mix of polynomial or combine, sometimes combine explicit mathematical structure with some advanced AI structure. So there are many ways people do people build the structure, and people also use hybrid structure. So once we select the structure, we estimate that structure, the model that use that structure. Estimate means, for example, y is equal to mx plus c. You estimate the m and the c. And then when you get the m, the c, you have the model. And you grasp the data, input-output data. Then you build the model by the estimation. Once you are satisfied with your estimation, for example, when you, for example, linear model, you do linear regression, and you measure the fitness of your model, the R-square value. And if you are satisfied with your R-square value, maybe you achieve 95% accuracy or better, then you say, okay, the model is good, and then you check for the model validation. See if the model perform well as by using other data that you do not use for the modeling. And this other data can be already measured data or can be fresh data. You apply a newly measured data, and once you see the outcome from the test, then you'll know whether your model is good to be used, or you need to go back and recheck your model estimation, or worse, you go back and use another structure, or maybe you don't have sufficient data, then you do more experiment or measurement of more data. So the first step, the experiment, you collect data, then you can measure outputs, or you can measure inputs, outputs, straightforward. Then the second step, the model structure. A model structure is a relationship. It can be explicit or it can be beyond explicit mathematical model. And normally this relationship describe the behavior of output in response to input, or just for time series, it's just describe the behavior of the process based on the single variable. And the common in system identification method, usually the models are divided into 3 categories. Black box model, this is the one Dr. Laila going to present afterward. And in fact, this, to me, frankly speaking, if you have quite complex or non-linear data or relationship between your input output, you can always try a black box model first. Black box model is actually, you know only the variable, maybe the outputs or the input outputs, but you do not know much about the relationship inside there. Maybe, for example, the pandemics now, the COVID-19. You know, at the back there, I'm doing some modeling for the COVID-19 cases to look at what's happening, comparing the worldwide event now. So, but I haven't come to any conclusion yet. So that COVID-19, for example, relating to locality and infection, you don't know the relationship. Of course, the UK is very famous using the R value relating the infection and also cases of relating the source of the infection. So they use the R value. But beside that, it's very difficult to judge. So for that sort of process or system, black box model can be good enough or excellent. And in fact, for any study that you have, any data that you have, you can try black box model. For gray box model, somehow you know the physical parameter relating to the output variable or to whatever variable that you are measuring. You know roughly. For example, generally, because of the school system, university system, we know that if people go to school, people go to university, people are cleverer in a certain unique definition. So you have some relationship that you know. Beyond that, you don't know. So that's gray box model. The rest of the model can be very explicit model or user-defined model, can be also hybrid model or based on theoretical proposal. So once I mentioned this one, we select our structure, then we carry out the estimation. And then using certain algorithm, there are many. The typical one, if you are using artificial neural network, for example, let's say feed-forward network, you forward the network algorithm, then you measure the performance of that network. And normally for feed-forward algorithm, the feed-forward neural network, the algorithm is called backpropagation algorithm. So you can use that algorithm where you backpropagate some of the error component in the training. And then based on the outcome from that training, you know the performance of your model. Then you can see whether the overall model is good or not. So sometimes model estimation is based on a simple test, whether the parameter you're setting to, for example, the y is equal to mx plus c, whether the m you estimate really compute your y to be on a general straight line, else you adjust again. And for y is equal to mx plus c, it's very simple regression, linear regression. For more knowledge, for example, the circular relationship, or we call it parabolic relationship, you may want to use, for example, Newton-Raphson iteration to iterate around and see whether you can converge to a very minimum error. And then once you satisfied with the model estimate, then you validate the model estimate. Normally, in system identification, either you examine the residual from comparing the outcome from your model or the output from your model compared to the original data, or we call it errors or residual, see how the residual behaves. Then based on the examination of the residual, you can sort of look at the histogram of the residual, whether it's follow the Gaussian distribution or not. If it's follow Gaussian distribution, that means you have a very natural errors coming from the model, that means your model is good. Or maybe you test your model with unused or new data and see the accuracy of the model, see whether it's within, or if your target is 95%, whether you can achieve above 90% or less. And if it's above your setup goal or your training estimate, then you can accept the model. Right, now I think it's a good time. If Dr. Laila is ready, I can pass over the presentation to Dr. Laila. Are you ready, Laila?
Yes.
Okay, let me just stop this presentation.
All right.
Okay, now I think it's pass to you.
Okay, I will continue from the PROF presentation. Okay, Prof. Can everyone hear me?
Please go ahead, Dr. Laila. Please go ahead.
Okay.
All right.
So for the Agarwood Essential Oil, okay, I would like to present for the Agarwood Essential Oil a case study is a part of our published journal in 2016. The title is on differentiating Agarwood oil quality using artificial neural network.
Can you put your presentation on, Laila?
Alright. Okay. Can nampak ke? Everyone can see the presentation slide?
No, it's not on.
No. Okay, no. Okay. On my side, it's already.
Yeah, you go right hand side bottom, present now, and select your window.
Okay. Present now. Okay. A window, right? Okay, done. Can everyone see that?
Yeah, okay, it's coming. Okay, that's good. Thank you.
Yes.
So I put on the slide view. Okay. So this is a case study that our team include Prof. NASIR already published in 2013. The application of the artificial neural network, which is one of the non-linear structure, as explained by Prof just now. Okay, the title is differentiating the Agarwood oil quality, okay, using ANN, artificial neural network. So from this, one of the application for the non-linear system to this Agarwood essential oil. Okay, as a background, Agarwood or Gaharu in Malay, okay, Jingkuh or Kanangkuh in Japan, is the resin impregnated hardwood of the Aqualaria species. Okay, a genus which belongs taxonomically to the Timilisia family. Okay, so why it is important? Okay, because the oil of this Agarwood or Gaharu got the highly demand in the market due to its multiple usage. Okay, such as as an instance in religious Yemeni, Buddhism, Hinduism, and Islamic. Not limited to that, it's also used as an ingredient in a perfumery industry and traditional medicine preparation in another region. Okay. Like others in Middle East countries, okay, it is a symbol of wealth and presence in the wedding ceremony. Normally, the incense has been burnt during the uh, wedding ceremony. So I also put two newspaper cutting regarding on the demand of this wood. Okay, wood or also agarwood. We talk about then about the challenges of quality grades. Okay, usually our current practice, okay, for this agarwood, the quality grading is used by using the human panel test, meaning that by refer to the physical properties of the oil, which is like odor, color, and long-lasting aroma, and this the grading method have got some problem like not accurate and it's very subjective to the person perspective. Okay, and this grading, okay, the Agarwood essential oil being graded and sold according to its grade. High quality is expensive and is being sold with the expensive price and vice versa. Okay, usually the high price is cost between USD 126 to USD 633 per tola. Tola is like 12 milliliter, a very little amount. Okay, so another price for the wood itself, okay, for low quality amount USD 19 per kilogram up to USD 100,000 per kilogram for superior or premier quality of the wood. Okay, so from here about the challenge of the quality for this group, for this Gaharu, so many researchers have highlighted that there is need instrumental intelligence so that it can be more accurately graded. Okay, so next is about the methodology on the ANN modeling, artificial neural network, like one of the non-linear model structure. Okay, so of course it start with the basically by the sample preparation, In this sample preparation, we have 96 samples of Agarwood Essential Oil from mixed quality, from high and low qualities. Okay, the samples were obtained from FRIM and also Bioaromatic Research Center of Excellence, UMP, University Malaysia Pahang. Okay, it's a collaboration. Okay, and after that, from this oil, we need to know the chemical composition. So we did the GCMS, gas chromatography mass spectrometry, okay, to identify the compounds inside the oil. Okay, and the input, okay, the outcome from the GCMS, okay, which is the abundances or the composition of the oil, we fed into the ANN modeling, okay, because we choose that one as our model structure, okay. And the detail on the ANN modeling, I will explain in the next slide. Okay, then results, we come up with the result discussion, also conclusion. Okay, for detail on the ANN modeling, okay, one of the nonlinear model structure selection. Okay, this is the parameter, the initial setting of artificial neural network. Okay, on our left, okay, the figure in our left, which is consists of input layer, okay, hidden layer in the middle, and output layer. Okay, so the input will be our the significant compounds as we identified from GCMS just now. Okay, there are a lot of compounds, and after we apply some techniques, okay, we identify only 7 compound that significant to differentiate between high and low quality. Okay, so this ANN we optimize the hidden nodes. Okay, and our output is the grade of the essential Agarwood essential oil, either high or low. So 1 node. Okay. So the inputs, as we can see from the slide, okay, there are chemical names, okay, from C1 until C7. Alright. So during the model estimation to train the network of this ANN, we have optimized 3 parameters, which is learning rate, momentum rate, and nodes in the layer. I also provide the result. Optimize meaning that we vary the nodes from 1 to 10 and we obtain the MSE, which is mean squared error. Okay, as we can see from the ANN final training errors with varying linear rate, we can see that at node 0.9, the MSE obtained the lowest amount of. So that will be used in our final design parameter. Okay, and for the second figures, the ANN final training errors with varying momentum rate. Okay, we can see that between 1 to 1, 0.7 have the lowest MSE, mean square error, the residuals. Alright, and the third parameter that we adjust during the estimation, the model, okay, or during we train the network, is ANN final training errors with varying nodes in the layer. Okay, excuse me, I forgot to tell that the data overall is 96%. In order to do this estimation and validation as well as testing, okay, we divide the data into the portion of 80% and 20%, meaning that 80% for estimation the model or to train the network, and 20% to order, okay, to validate the model, right, the developed model. So this, we split the data after we randomize it, so it is fair, okay. So from 3 learning parameters that we have optimized just now with the lowest MSE for each other, okay, we come up with the last final ANN final design parameter, which is 7 nodes in input layer represented by 7 compound just now that significant to differentiate between high and low. And our objective, our target or output is nodes in layer which is high and low. Output layer is 1 and nodes in the layer which is 2 nodes in the layer as represented by the graph. and learning rate is 0.9 and momentum rate is 0.7. Okay, and with the additional extra. Okay, so once we have predict or estimate the training network, okay, like Prof said just now, we regress it into a regression line or best fit. Best fitting meaning that the close between the expected to the actual data. Okay, so from here we got R value is 0.99256, which is very close. The predicted, okay, the regression line is very close to the actual data. Okay, so the output like Prof said just now, y equal to mx plus c. So m is at 0.95 and c is 0.0292. Okay, so I also provide the prediction for the network. Okay, and also the prediction errors of the AN training. Okay, so if you can see from the prediction errors for AN training, the error we can see that very close, very small, between 0 to 0.3. The highest peak here is 0.3, okay, of the errors or residuals. This one for the prediction of errors for AN training. Okay, so this is all done by the 80% of the data, meaning that 77. Okay, so next, after we have estimate the model or train the network, it is about to test the developed model or network, either it is we can accept or not. Okay, like we can see from the flowchart Prof provide just now. From the number 3 we estimate, and then model validation. So this is the result for the model validation. All right. So for the classification of AN training using the training data part, alhamdulillah, we managed to obtain the 100% accuracy with the other parameter like sensitivity, specificity, and precision. Okay, there's also we occupied also with the coefficient matrix. The theory part can be in the paper, alright. And okay, for the testing part, using the 20% of the data, which is from the figure, it is 19 samples. Okay, we used to validate or to estimate, to test the developed model. Alhamdulillah, we also obtain 100% of the accuracy, meaning that for this model, the model is successfully can differentiate between high and low quality using the sample under test. Okay, so for the testing also, the accuracy, sensitivity, specificity, and precision also we manage obtain the 100%. Okay, alright. So as a conclusion, okay, I will pass to the Prof to conclude this.
Laila, you can continue or not? Just continue.
Just continue. Okay. So as a conclusion, this paper, okay, and this study from our team managed to calculate that Agarwood Essential Oil quality grade just now can be determined accurately. Okay, it is very simple and fast system. Okay, and repetitive and very reliable, meaning that it can solve the problem that we need to that currently used by the human panel test, which is the result very subjective because it depends on the human perspective. Okay, some people say, oh, this is not strong enough. Some people say, oh, this is not this is enough long lasting aroma. So it's very subjective. However, by using this artificial intelligence technique or system modeling, okay, the result is even we repeat it every time, but the system the result is accurate and can be reliable. Okay, so and now, okay, our team also now have a service to differentiate this oil and already got the customers from the industry. We have several loyal customers to differentiate their Agarwood Essential Oil already. Okay, so this meaning that UiTM already offer this required service to the whole world, to the world outside, and this technique, artificial neural network, not only can apply to the Agarwood Essential Oil but also to the similar system. I think that's all from me, Prof. Thank you so much.
Okay, I think, can you go to the next slide?
All right.
Right, I think you can mention that.
Okay, thank you. Thank you. And acknowledgement. acknowledgement. Our team for this study would like to acknowledge the UiTM, okay, MOHD for the grants to support our study, to Faculty of Electrical Engineering, okay, and Research Lab, to the frame, especially to the Natural Product Division, led by Dr. Nur Azhar Muhammad Ali, and to Bioaromatic Research Center of Excellence, which is Professor Madya, Dr. Saiful Nizam Tajuddin, also director of that center from the UMP Pahang. Okay, thank you so much to Mitrans for this opportunity to share this knowledge. Okay, to Prof. Nasir, to Dr. Wan Madlina.
Okay, excellent, Dr. Laila. Just a closing remark.
All right.
I would like to thank everybody for paying attention. Those who wanted to have the slide copies, please email us and then we can email you the copy of slide later on. And in fact, if you are on our database, we'll let you know of our advanced course later on. And in fact, we're going to have some hands-on work on the Agarwood oil.
Yes, sure.
I think maybe after PKP and after Raya later on. So yep. If you email us and keep us to know your email, your contact, you can get the copy of the slide and also the information about future courses. Right, I would like to take this opportunity also to thank Dr. Laila herself for, in fact, she's not well today, but she got so excited. She, I think, given normal circumstances, she might not be able to walk, maybe, or I don't know, or stand up. But I'm not going to dwell that on that. But I think thanks so much to Laila, and I would like to thank Dr. Wan Madlina for organizing this through Mitrans, and for you all. There are many more courses coming via Mitrans. But finally, one final point. This certification for Agarwood quality now, we are bringing this program under the Halal Supply Chain of Mitrans. So for your info, there are many other certification for halal supply chain we are doing under Mitrans. So I hope out there, especially Muslim, if you want to get involved more, collaborate with us, please. And then we have in the pipeline some more work planned out for training and also for certification. Again, I would like to wish happy Eid al-Fitri for Muslim, and hopefully you benefit something from our presentation today. Thank you very much. Assalamualaikum and bye-bye everybody. Dr. Wan, maybe you want to say a few words, last word?
Yes, thank you so much, Prof. and Dr. NURLAILA. Thank you for making it happen. I apologize to all the participants for the technical glitch just now. I couldn't find to unmute some of the participants who are on who on their mic. Okay, I apologize for any shortcoming. We will be organizing again tomorrow. We have two webinar. One is from Dr. Kabir. We will keep on posting on UiTM website and UiTM email. Please join us, okay, tomorrow. Another one is from Puan Fatin on the SketchUp software. Okay, and inshallah after Raya we will have a few more interesting topic to be on webinar. I hope you all will join. And I already posted the feedback form, and your feedback is very important to us so we could improve in the future. Thank you so much. Thank you for coming, and hope to see you all again. Assalamualaikum. Thank you, Prof.
Waalaikumsalam.